Hey everyone, we are back and we are going to look at chapter 1.1 in the book, which is about solving algebraic equations. And hopefully you've seen some of this before. If you haven't, then you're going to see it for the first time here, and that's okay. Oh, let me move my picture. There we go. That's much better. So let me get a new page. There we go. So first thing, there's a rule in math, the zero factor rule, I think it's called. If you have something a times b equals 0, the only way this can be true is if a equals 0 or if b equals 0. It's the only way this can happen. A can't be a half and b equals 2 because that'll give you a 1. In order to be a 0, a has to be 0 or b has to be 0. Okay, I think you all will accept that. Not rocket science. But now let's look at something like x times x minus 1 times x plus 2 equals 0. If we need to solve for this, we use that zero factor rule and say that either x equals 0 or x minus 1 equals 0 or x plus 2 equals 0. Well, x equals 0, I got that one. If I solve for x here, x is equal to 1. So there's another solution. Then I solve for x here, x is equal to minus 2. There's another solution. So there's 3 solutions to this, that each one of these, if we use one of those 3 x's in here, it will turn one of these factors into 0 and turn the whole equation to 0. So this is how we solve something that is factored like this, okay? Now, it's convenient when they're already factored like that, then it's really easy. But if we have x squared minus 6x plus 8 equal to 0, well, this is something that has to be factored. And so to do this for factoring, I make a little table here. So I'm going to make 8, factors of 8. So I could, let's see, how could I do that with 2 numbers? I could make it with a 1 times an 8, or a 2 times a 4, or that's about it. 4 times 2 is the same as 2 times 4. We don't care. And it's positive, so I'm using both positives. Oh, wait, I could use negatives. Minus 1 and minus 8, and minus 2 and minus 4. And I know this might be important because I have a negative sign here. If I had a positive sign here, then I don't need any of these negative ones down here. But I do have a negative sign there, so I need these. And recall when we factor something, x minus a times x minus b, when I multiply this out, I'm going to have x squared minus bx minus ax, and minus times minus is positive, plus ab. And I'll group these together. I'm going to group these together, b plus a. So notice, well, let me do it the other way here. Hang on. That might be confusing. So I'm going to put the plus x here, and I'm going to write this as minus a minus b. So minus a minus b. That's a terrible little bracket. Whoop, whoop, there we go. That's a little better. So minus a minus b, that's this number here plus that number combined to give me this number here. These terms here, which is the, let's see, outside 2 and the inside 2, are commonly referred to as the cross terms. So I will talk about them as cross terms a lot. So the cross terms are generated by the minus a and the minus b being combined together. That will always be the case. So when I'm factoring something, and notice these two things also multiply together to give me the last one. So I need to keep that in mind when I'm looking at the factors here of 8, that I'm finding numbers that will multiply together to give me this, like I have here, and will add together to give me a -6. Well, add together, that'll give me a 9, that'll give me a 6, a -9, ooh, -6. So these two multiply together to give me 8, they add together to give me -6, bingo. I can write this as x minus 2 times x minus 4 equals 0. And just for fun, and it is an awful lot of fun, let's check it. So we get first 2, so I'm doing FOIL again, x squared, outside 2, minus 4x, inside 2, minus 2x, last 2, plus 8. So x squared minus 4 minus 2 is minus 6x plus 8 equals 0. So I just wanted to prove I didn't lie to you. So if we take, so this works out, so this is the proper form. So if I look at this and I ask, well, what's the solution? What's x equal? Well, either x is x minus 2 equals 0, or x minus 4 equals 0. So that means x has to equal 2 or x has to equal 4. These are the solutions. Okay? This is how we solve a polynomial like this that can be factored. It's always ideal when they can be factored because this is always the easiest way to do it. Sometimes it can't be factored, and that's why we use completing the square like we talked about last time, or the quadratic formula like we talked about last time. So let's take another one. X cubed minus 6x squared plus 8, plus 8x. Well, that's not an x squared thing. That's an x cubed thing. That's totally different. But aha, there is an x in every term. So I can start out by factoring an x out everywhere. So if I factor an x out, I will leave behind here an x squared. I will leave, if I take one x away, I'll be left with minus 6x. And if I take one x away here, I'll be left with 8. And this one we just did. That was x minus 4 times x minus 2 equals 0. So now the things that will turn this factor to 0 is x equals 0. For this one, we found it was x equals 4. And for this one, we found it was x equals 2. So the solutions here are x equals 0, 2, and 4. I see the x cubed, and I think, uh-oh, this might be hard, but nope, there's an x in every one, so I can factor the x out, and that makes it easy. So don't freak out when you see an x cubed. We're not going to factor x cubed functions, but well, if they don't do that, if we can't take something out right away. Okay, so now, is this one of the examples in the book? Probably, but I don't know which one. Here's another one. X squared equals 10 minus 4x. Now, many people think about, oh, I'll just take a square root. Well, if you take a square root of both sides, you're going to get x here, but this thing, 10 minus 4x, is nothing. You can't do anything. Even if it was 16 minus 4x, so it was a perfect square, this does not equal 4 minus 2x. You cannot distribute the square root across a sum or difference because a square root is the same as x to the 1/2. These two things are identical. Square root and x to the 1/2 are the same. And you cannot distribute an exponent across a difference. No, no, no. Bad. Bad student. Bad. Can't do that. So, oops. Let me get rid of that ugly thing. There we go. So all we can do, I'm just going to rewrite it. I got my pen. Yep. So let's just take this and rewrite it. X squared equals 10 minus 4x. We need to get everything on one side and 0 on the other to see if we can factor it. So I'm going to subtract 10 and add 4x. So we'll get x squared plus 4x, that's an x, not a, I don't know what that was, minus 10 equals 0. Okay, now we got to look at this and ask, what are the factors of 10? Okay, so for minus 10, it would be 1 and negative 10, or negative 1 and 10, or 2 and negative 5, or negative 2 and 5, and that's it. Do any of these add up to give me the middle number, to give me a plus 4? This will give me a plus 9, that's close. This will give me a plus 3, that's close, but it's not plus 4. So this means this cannot be factored. So we're out of luck with the easy way. So now we got to do it the hard way. And we could complete the square or do the quadratic formula. So I'll start with the quadratic formula. Let's do that in blue. So a equals 1, b equals 4, c equals negative 10. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so x equals, draw your long divisor line, like I said the other time, minus 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 10, all over 2a, 2 times 1. So that'll be x equals minus 4 plus or minus the square root of 16. Minus times minus is a plus, plus 40 all over 2. So this is minus 4 plus or minus the square root of 56 over 2. So we'd think, well, maybe we can't do anything with that. Probably can't, but we got to think about 56, and are there ways to simplify this? For example, if we had square root of 8, we would not leave it as square root of 8 because this can be simplified as the square root of 4 times 2, which is the same as square root of 4 times square root of 2. Square root of 4, we know that is 2 radical 2. So we would not write something as square root of 8. We would write it as square root of, as 2 times square root of 2. Oops. Uh-oh. Did I get it? Let's see. Oh, I did not. Okay. Dang it, I hate this thing. Okay, that'll have to be good enough. Okay, so 56, we got to think of the factors of that. And that's 56 is 7 times 8, right? Which is 7 times 4 times 2. Ah, there's a perfect square. So I could write this as minus 4 plus or minus square root of 4 times 7 times 2 is 14. Okay, now that's this gotta go. Okay, so over 2. So square root of 4, I can take this out of the radical, and I could write it as minus 4 plus or minus. The 4 comes out of the square root, and it becomes a 2. And now I can divide this by 2 and divide that pair by 2. I'll get minus 2 plus or minus. The 2's will cancel when I divide those two. Radical 14. So this is the answer for the quadratic equation. And then let me get rid of that. And now we'll do completing the square. Because, why, you ask? Because it's fun. Okay, let's go purple. A little dark purple. There we go. A little royal purple. So for completing the square, step one was put x's on one side of the equation and all the constants on the other. Step two, take this number, divide it by 2, and then square it. And that's what we add to both sides. So we'll add a 4 here, and we'll add a 4 here. Then I write this as a perfect square, and it's going to be x plus the number I got when I divided that by 2. X plus 2 squared equals 14. Then we take a square root of both sides. Square root of this and square root of that. Square root of x plus 2 squared will give me x plus 2. Square root of 14, can't do anything. It's just going to be plus or minus square root of 14. So I took the plus or minus I would have gotten from here and I stuck it over to there. So now I do x equals, I subtract the 2, minus 2, plus or minus square root of 14. Look at that, the same answer. I'm going to say this is easier. The only time this is not easier is if this was a 5. So if you had x squared plus 5x minus 10, and then you did x squared plus 5x equals plus 10. So I take half that number, 5 over 2, and then I'm going to square it. So we're going to get 25 over 4. Well, that's kind of weird. And then we got to add that to both sides. So now this gets really uncomfortably weird. So we're going to have, you could write it as a decimal. So that would be 24, so 6.25. You could do that. X squared plus 5x plus 6.25 equals 10 plus 6.25. Then you can write it as x plus the thing you got when you chopped it in half, 16.25, and you can keep going from there. When this is odd, you really got to shift it to a decimal, or you have all these big honking fractions floating around and it becomes a real pain. And you don't want to mess with that. So I tend to see this as when it's odd, I'm going to use the quadratic formula. When it's even, I think the completing the square is an easier way to do it, and I'll do that. It's up to you how you want to do it. Most people don't like this because they have to remember the process, and they'd rather plug it into the quadratic formula. However, there's a lot of opportunities to make negative sign errors with the quadratic formula. And so I would suggest that's the means of last resort whenever you use it. Don't save. Okay. So here's one, 2x squared plus 5x minus 3 equals 0. Oh, okay, so it looks like it's a factoring thing. And so we have to make a negative 3. So we could do minus 1 and 3 or 1 and minus 3. But neither of these are going to add up to give us that because we have a 2 here. So we're going to have 2x plus something, and I don't know, x plus something, b. So when we do the first 2, we'll get 2x squared like that. But the outside 2 is going to be a 2x times b. And the inside 2 is going to be ab. So you got this extra 2 here to mess things up. Oops, ax. So that tends to make it difficult. And so we got to be careful with that. Where am I going? Okay, I am going to pause for a minute. Okay, I'm back. My cats were into something and I didn't know what it was. It was a sound I had not heard before, so I was worried. So, okay, so here we're going to try to factor this one. And we're trying to make a negative 3, so we got our factors, but we're also going to have a 2 that's going to multiply one of these together. So if we put the 2 here, this would give me a minus 2 plus 3 would give me a 1. That's not going to work. This would give me a plus 2 minus 3 would give me a minus 1. So putting the 2 with the 1 isn't going to work. If I put the 2 with the 3, this will give me a minus 1. That'll give me a 6. Minus 1 plus 6 will give me a 5. Ding, 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 ding. There we are. We'll get a 5, which is what we need here. So I want to set it up so the 2x gets multiplied against the 3. So I want to put the 3 here, so when these get multiplied together, right, first 2, outside 2, inside 2, last 2. I want the outside 2 here to be 2 times 3, so I'll get a 6. So when I take away 1, I'll get a 5. And this is going to be a positive 3, because that's what I used here, and this will be a negative 1. So if I check it, 2x squared plus 6x minus x minus 3. 2x squared plus 5x minus 3. I am awesome. Okay, so this works. So now I got to write a solution though. So the options are either 2x minus 1 equals 0 or x plus 3 equals 0. So if I solve this for x, 2x equals 1, x equals 1/2, or x equals minus 3. These are our two solutions. Okay? It's not any fun when this is here. If you're going to do completing the square with something like this, then I don't know of any tricks to make it easy. If I was going to do completing the square, I would do the first step, get that over there, then I would divide everything by 2. So this would be x squared plus, plus 5/2 x equals 3/2. And now with a fraction here, you write it x squared plus 5/2 is 2.5 equals 1.5. You'll probably do it in decimal form maybe. Might be a hassle. So you need to play with that and see if you would rather do it that way than factor it. Sometimes when this is a big number, if that's a big number, if it's 8x squared plus 5x minus 3, well, now this is a problem because you're trying to make a negative 3. So 1, negative 3, negative 1, 3. But 8, you don't know if it's an 8 and a 1 or a 4 and a 2 or a 2 and a 4. So when I have a big number here, I never try to factor it. I go straight to the quadratic formula because it's just too hard to do. It takes too long. If it's on a test, you're going to eat up too much time figuring that out when you can just muscle your way through the quadratic formula. You know that's going to work. You just got to be careful with minus signs. Okay? So let's look at this one. This is problem number 31 in the textbook. It looks like fun. Let's do it. Okay. I would call this a good test or quiz question, I think. I wouldn't have any questions about making it as such. I think we might have done this one in a previous video, did we? I don't know. Okay, so first thing I'm going to do is I'm going to FOIL this bad boy out. So 2x squared minus 5x plus 2. So that'll give me x squared minus 2x minus 3x plus 6 and then a plus 3x. That guy's kind of there for the ride. Okay, 2x squared minus 5x plus 2. So x squared minus 2 minus 3 minus 5x plus 6 plus 3x. Oh, so before I do anything, I see a minus 5x and a minus 5x. So I'm going to cancel those two out. And I'm going to show I'm canceling them with my little arrow thing there. 2x squared plus 2 equals x squared plus 3x plus 6. So I'm going to do a minus x squared minus 3x minus 6 to both sides. Minus x squared minus 3x minus 6. And then I'm going to add. So 2x squared minus 1x squared, x squared minus 3x. 6 minus 2 is minus 4. Okay, so for 4, we can do minus 4. We can do minus 1 and 4, 1 and minus 4, or 2 and negative 2. And we need them to add up to minus 3. So I think this one, ding, 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 is going to be the one that's going to do it. So this will be x plus 1, x minus 4 equals 0. So x equals minus 1 and 4. That was fun. Is that it for us? I think so. So a lot of these are just applying the strategies of factoring or completing the square or doing the FOIL. So you need to just look at those. There's some really good examples in the book. Oh, we'll do one more because it'll be fun. This is number 35. What are you doing, Kat? I was trying to get up on the shelves. If there's a shelf, they want to get on it. X times x plus 7 equals 14. What are you doing? Oh my God. Okay, so to do this, I got to multiply it out. So this will be x squared plus 7x equals 14. I could do completing the square because I'm already set up for it, but it's an odd number. I don't really like odd numbers because then I got fractions and I like to keep the fractions. So I am going to, well, let's see if we can factor this. I bet we can't, especially since I know the answer. So 14 minus 14, it'd be minus 1, 14, 1 minus 14, 2, negative 7, minus 2, 7. Well, those aren't going to add up to 7, so that ain't going to work. So we need to try something else. Oh, get away, go away. Oh, okay. So now I'm going to use a quadratic equation because it's fun. Oh, C equals minus 14. And I always write the equation so I have it to look at it. I can't tell you how many times people just write the equation wrong and they start jamming numbers in without the formula to look at. So write the formula first. Do yourself a favor. It's not that big of a deal. You're still cool if you don't do it, boys and girls. So let's see, minus b, minus 7, plus or minus the square root of b squared, 7 squared. No negative sign, I don't have to worry about parentheses. Minus 4 times a times c. Unfortunately, I made a long divisor line, so I covered it all over 2a. Here's a big source of error that people do 2a and you're used to it being a 1, so you just write the 2 down here. But if a isn't 1, you got to remember to stick it in down there, especially if it's a negative. Okay, so x equals, big long divisor line, minus 7 plus or minus 49. 4 times 14 is 40, 56. So plus 56. Is that right? Yeah, 40 and 16. Yep, all over 2a. So this will be minus 7 plus or minus. I need a calculator. Where's my calculator? Hello, calculator. Oh, there it is. It looks like that's 105. 49 plus 56, 105. All over 2. So now we got to think about, are there any perfect squares in here? Is there a 9? 105 divided by 9? No. Is there a 16? That seems doubtful. I think we're probably, it's not a 25. It's not can't be a 4. Because if it was 4, then it would end up even. So is there a 3? No, 3 doesn't matter because it's not a perfect square. So I don't think we can simplify this. Maybe I'm wrong. You could, I bet, find a website and say, find the factors of 104. And I don't think there's any perfect squares in there. You can't divide it by 2. I usually start with 2s. Can't divide it by any even number. So there's no 4s. There's no 16s. There's no 36s, because if this is a factor, if you're going to divide it by an even number, you're going to get an even number out as an answer, as I recall. So no even numbers, so that leaves odd numbers, 9, and this is not divisible by 9, is it? Did I try that already? Yeah, you get lots of decimals. So 9, 25, it's not going to work. 36, 49, that's not going to work. So this can't be simplified. So here's our answer. Okay, so that wasn't so terrible, right? Using the quadratic equation. You just got to be careful. And if you write it out like this, and you write what A, B, and C are, that dramatically reduces the chance for error. Okay, I strongly recommend to do that. Okay, so that's it for 1.1. We're going to jump into 1.2 right away here. Bye.